In this particular question, we have a type of fruit which is normally distributed with an average weight of 4.2 kilos. I'll start highlighting all the key bits of information here. So that 4.2 kilos, standard deviation of 0.6 kilos, and a batch of these fruits is being sorted. Extra large is considered if it's greater than 5 kilos. So what's the chances that this fruit weighs no more than 0.3 kilos above the extra large threshold given, all right, given it has already reached 5 kilos in weight? So first of all, we've got to understand what distribution this is. And importantly, this is a normal distribution, okay? So it's a norm dist. And what we can say is that our mean is equal to 4.2, and our standard deviation is equal to 0.6. So what you might have seen in the past is that x is a norm, right? And you can say that your mean is equal to 4.2 and your standard deviation is equal to 0.6. Now that just lets the marker know what this variable x is, okay? And it also lets them know that you know that it's looking like this kind of bell curve thing with 4.2 here and 2 bars. We've got the bar in red, that's the extra large. And then the bar in like a light blue here, so 0.3 plus 5 is equal to 5.3. Okay, and that will let us know. So basically, we're trying to find this. So it says, what are the chances that fruit is no more than 0.3? So we're trying to find this area here, given that the red area is now 100%. Okay, there's an equation that we use quite often in probability. And it's like the probability of event A given that event B has occurred is equal to the probability of event A and B, right? Given or divided by this. So that basically ignores all of this and now makes the red patch 100%. Okay, so how do we write this? The next step to write this with maths is saying that the probability of x being less than or equal to 5.3, given that, right, given that x is equal to or greater than or equal to 5, right? So that's what we need to do. And that is equal to the probability of between 5 and x of 5.3, right? All divided by the probability of greater than 5. Okay, so let's figure out this bottom bit here first. So I always find drawing the normal distribution really helpful. So once I've drawn it, I know that I'm trying to find this red bit. So let's go to the calculator, let's go to main, let's go to interactive, and then we go to distribution, and we go to its continuous, and we want the CDF, the cumulative one. Our lower function here is going to be 5. Our upper is in Math 2, that's infinity. And our standard deviation in this case is 0.6, and our mean is 4.2. And when we click that, it gives us 0.09. So we can say this is equal to 0.09 and 12, right? Dot, 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 dot. And you can say use calc, or that's okay. And now we can now figure out this particular one, x 5.3. And again, we can go to interactive distribution, continuous normal CDF. Our lower bound is 5, but our upper bound this time is 5.3. So we can see that's the blue line there. And then we say that is 0.6 for our standard deviation and 4.2 there. That gives us a slightly lower number of 0.05 7, 8. Okay, therefore, we now write the probability of x being less than 5.3, given that x is greater than 5, is now equal to 0.0578, all divided by a 0.0912. And this will give us our final answer. We can just highlight the one that we want, put it down the bottom. Highlight this one, put it here, and then I'm going to times it by 100 later actually, but this is equal to 0.634, which is basically like saying 63.4%. At the marker O, we've rounded to 3 sig figs, or in this case, really given like a one significant figure, but this is fine. 3 significant figures is all good. So the key here, what might be a bit confusing, is this given that equation. And I guess what we want to say is that it's now out of only 0.0912, or like 9% of the total area now. It's only 9%, this red patch here. So that should be 100%. Now, we've got plenty of questions like this on our website. We also offer tutoring services. So if you need any help, let us know. We would love to provide assistance. So reach out. Otherwise, like the video, share it with friends if you found it helpful.